Hi everybody, so this is the video for section F. We have made it. This is what we've been building towards for the whole unit, is how do we use matrices to solve simultaneous equations. It's what matrices were originally designed to do. It was their first kind of purpose, and now here we are, we've made it. Okay, so a system of linear equations can be written in matrix form. So we've got two linear equations that we want to solve simultaneously. So before today, you might have tried substitution, you might have tried elimination, you might have tried graphing them and finding the point where they cross. Now we're adding a fourth method to our toolbox for how to solve these simultaneous equations. So the way that we convert it, I guess for lack of a better word, from this equation form to matrix form is we set up three different matrices. So the first matrix is for coefficients. So we've got a coefficient in our top equation of 3 and -4. So we've got 3 and -4. Our bottom equation has coefficients of 2 and 5. Second matrix is the matrix of the unknowns, so x and y. And then the last matrix is the matrix of the constants, 17 and -8. So hopefully it goes without saying that these have to be written in general form, the x and the y on the same side, in order to sort of put them into this form with the matrices. So that's how you take a set of linear equations and convert them into a series of matrices. So now that we know how to do that, how do we then solve that for x and y? So I'm going to move down here to a second example, and we're going to go all the way through this, one little tiny bit at a time. So we want to solve for x and y. So here's our system of equations. So step number one, make them into the system of matrices that we saw above. So we've got our coefficients 2, 3, 5, 4. We've got our unknowns, x and y. And we've got our constants, 2 and 12. So when you're solving an equation, you want the unknowns by themselves. So we want these unknowns to stay here, and we want to get rid of this matrix and put it over there. Now these two matrices are multiplying together. So in theory, we could divide both sides by that matrix, and that would get rid of it on that side. However, we can't divide matrices, right? But we can multiply by the inverse. So what we're going to do is we're going to multiply both sides by the inverse, then that's going to cancel out that side. So we end up with x and y equals, and on our other side now we've got 2, 3, 5, 4 to the power of -1. That's the inverse of that. And then we still have our 2, 12. I deliberately put this one in front because we're going to have to do the inverse before we ever do the multiplication. So it's just, I think, a little bit, well, actually we're not, but that's fine. I'm going to put it at the front anyway. Okay, so now, last video we talked about how to find the inverse. So if you'll recall, inverse 1 over the determinant, and then we've got that reshuffled, rearranged sort of matrix. So this is what we need to figure out for this matrix. So for the moment, my x and y are going to stay. And then I need to do 1 over the determinant of this. So the determinant AD, 8 minus BC, so minus 15. And then I need to multiply that by that rearranged version. So the 2 and the 4 will swap places. The 3 will become negative, and the 5 will become negative. And then I still have that 2, 12. So now I've got three things multiplying together. In theory, you can do them in whatever order you want. In practice, it is much easier to multiply these together before this multiplies onto this and we end up with a bunch of fractions. You can do it that way. It will just mean that you're in for a bit of a more difficult time. So I'm going to suggest multiplying those together first. I don't know why I put the line there. 2, So for the moment, x and y will stay as they are. I'm going to simplify that down to be 1 over negative 7. And then I've got this multiplication here. So again, row by column. So I've got 4 times 2 plus negative 3 times 12. And then negative 5 times 2 plus 2 times 12. So you'll see that almost everything is coming back in this one particular question. So we've been building this whole unit for this one question. Okay, so now I've got 8 plus negative 36. So negative 28, and I've got negative 10 plus 24, so 14. You'll know you're on the right track if you see that when you have to do this multiplication of this fraction, that it's going to work out nicely. Because almost all of these questions will in fact work out quite nicely. So now we're going to multiply this by both of the elements in our matrix. So now we've got 1 over negative 7 times negative 28, which gives me negative 28 over negative 7, which gives me 4. And then I've got 1 over negative 7 times 14, which gives me 14 over negative 7, which gives me negative 2. And now I've got 2 identical, equal matrices where I know that the elements that are in exactly the same position are going to be the same. So therefore, 3 dots, x equals 4 and y equals negative 2. So that one question just pulled together almost every single thing we've done in this unit, which is sort of interesting. The whole purpose of matrices in the beginning was to be able to do what we just did there. If you were to do this on your calculator, you need to get to this point. And then once you get to that point, you can put that in your calculator. So if I were to pull my calculator up here, clear that, I need to go into my matrix menu, and the first thing I need to do is edit some matrices. So first matrix I'm going to put in is a 2 by 2. And it's the 2, 3, 5, 4, 1. And then I need to edit another one because I need this 2 by 12 one. So I'm going to put that in as matrix B. And it is a 2 by 1. And it's 2 and 12. And then if I go out of that, then what I want to do is I want to multiply the inverse of what I just put in as A times B. So I've got to recall the name of A, and I'm going to do the inverse of A times, and then I need to recall B. So now that's exactly what's written out here. I put in this as matrix A, so I've got A to the power of negative 1, the inverse of A, and I put this one in as B. So that's what goes in there. And then if I hit enter, I get 4 over negative 2, and that's what I got down here. X is equal to 4, y is equal to negative 2. All right, so that about does it for section F.